Hi class, I want to take a look at an example where they ask us to draw a tangent line to the curve. Okay, so I'm going to do that and more, and I know this takes up a lot of class time, so I wanted to get an example to you that you could spend some time on. Okay, so we're in section 2.4, page 92, problem number 12. I think it'd be great if you did this along with us. Okay, so they ask us to find the tangent line to this curve when x equals 0. Okay, so obviously we're talking about through this point right here. From our graph, obviously, we can see the coordinates of this point are 0, -1. However, if we ever needed to calculate that, we know the x-coordinate, so to figure out the y-coordinate, we just evaluate the function f at 0. So wherever we see x, we plug in 0, and we get -1. Okay, so obviously that gives us an x-coordinate of 0 and a y-coordinate of -1. Okay, so what they're asking us to do in this problem is find the equation of this tangent line that goes through this point. Okay, so I'm going to try my best to draw it. That's a pretty bad drawing. But anyways, they're asking us to find the equation of that line. Okay, and remember from pre-calculus, when you want to find the equation of a line, you'll use this formula right here. This is the point-slope formula. In order to use the point-slope formula, you need a point, so you can get x1 and y1, and you need a slope, so you can get m. And once you know those two things, you have the equation of the line, so that's great. Obviously, we have a point. The hard part here is going to be finding the slope of the tangent line. Okay, so I'm going to go to the next screen where we have a little bit more room and we can show those calculations. But remember, in general, what we do to find the slope is we just pick a point. Let's say the coordinates of this point are x and f of x. And then we find some other point close to it that has an x-coordinate of x plus just a little bit. So x plus h. And so its y-coordinate is going to be f of x plus h. Okay, and so what we're going to do is we're going to find the slope of the line that goes through these 2 points. Alright, since it goes through 2 points, we call that a secant line. But what we're going to do is we're going to make h really, really small. So we're going to bring this point closer and closer and closer and closer until it's practically right on top of the first point. Alright, so h is going to be the smallest number we can think of. So basically it's only going through 1 point, and we're going to call that the tangent line. Okay, or the slope that we get, we're going to call the slope of the tangent line. Okay, so let's go through that calculation in the next slide. Okay, so remember we have 2 points. The first point has an x-coordinate of x and a y-coordinate of f of x. And the second point has an x-coordinate of x plus just a little bit more. And so when we evaluate the function, it'll be f of x plus h. All right, so we want to find the slope in between these 2 points. Remember, slope is simply change in y over change in x, right? So let's calculate that. The change in y, f of x plus h, minus f of x. So we're just subtracting the 2 y-coordinates over the change in x. And what's the difference between x plus h and x? Well, that difference is just h. All right, so that's the slope of the secant line. But remember, we want the slope of the tangent line. So we want to bring those 2 points together so that the distance in between those 2 points is non-existent. So we're going to evaluate this expression where h approaches 0. Now h can't actually be 0, because if we plug in 0 here and we plug in 0 here, we'll have f of x minus f of x over 0. So we'll get 0 over 0, which is bad news. So what we need to do is a little bit of a trick, and we need to evaluate this algebraically. Okay, so see if you can follow along with me. So we're going to take the limit as h approaches 0 of f of x plus h. So what that means is wherever I see x in f of x, I'm going to replace each of the x's with x plus h. All right, so there is f of x plus h. Now I got to subtract off f of x. So this is f of x right here. But I got to subtract off the whole thing, so I got to be careful about my parentheses. And then over h still. All right, so now we got to do a little bit more simplifying. Actually, a lot more simplifying. So x plus h squared, x squared plus 2xh plus h squared. We wrote this twice and FOILed it out. Now I'm going to be careful about distributing the -3. Then we got -1. Now I'm going to be careful about distributing the negative sign. Alright, so the top looks really long and intimidating, but trust me, it cleans up a little bit. For example, x squared, positive x squared, and negative x squared, canceling out. Negative 3x and positive 3x, canceling out. Negative 1, positive 1, canceling out. Isn't that nice? Alright, so let's see what we got left here. Limit as h approaches 0, 2xh plus h squared minus 3h over h. Alright, can we evaluate it by substitution now? Nope, I'll still get 0 over 0. So I'm going to look for something else to do. I'm noticing something nice here, and this will usually happen. Every term on top has an h, so I'm going to divide every term by h, since that's what we're doing here. So I'm going to have 2x plus h minus 3. Oops, I forgot my limit statement still, because I haven't evaluated the limit yet. Alright, so I'm going to take the limit of 2x plus h minus 3. Now I can go ahead and evaluate the limit using substitution. Okay, since plugging in 0 for h now doesn't create any problems, I have 2x plus 3. Alright, so we'll talk more about what this actually is here, but this is a derivative that we just calculated. Alright, but we'll explain the meaning of that a little bit more. Anyways, in this case, we just calculated the slope in between 2 points that were infinitely close together, so basically we found the slope of the tangent line. And remember, we're going through the point 0, negative 1, right? So if we want to figure out the slope through this point, x is 0, right? So we just plug in 0. For some reason I turned that into a plus 3. Sorry, it should be a minus 3. So we evaluate this at 0 when x equals 0. And we will get negative 3 as our slope. Let's go back to the previous slide. Does it look like negative 3 is a reasonable slope for this tangent line? I think so. I think that's pretty good. Okay, so the slope of this tangent line according to our calculations is negative 3. So let's crank this through our point slope formula. Y minus the y coordinate of the point is negative 1 equals m, the slope is negative 3. X minus the x coordinate of the point is 0. Alright, so if we do some simplifying, y plus 1 equals negative 3x. Let's put in y equals mx plus b form. And that's what we get. Alright, so that is the slope of the tangent line. Alright, now let's calculate the slope of the normal line. Remember, the normal line is just going to be the line through the same point, but has a perpendicular slope. Okay, so y minus y1 equals m times x minus x1. We're going to use the same point, so y minus negative 1 equals, now our slope is going to be the opposite reciprocal. So the opposite reciprocal of negative 3 is going to be 1/3. X minus the x coordinate is 0, so we're going to get y equals 1/3 x minus 1 after we simplify. Alright, so that is going to be the normal line. Alright, let's double check it using GeoGebra, but I think that's looking pretty good. Alright, so here we have GeoGebra. Just plugged in the equation of our curve and put a point on our curve where we want to find the tangent line and the normal line. Okay, so the first thing I'm going to do is I'm just going to draw the tangent line using GeoGebra. So I've got my point. I'm going to come to this option, which lets us draw lines. I'm going to select tangent lines. I want it through this point, tangent to this curve. And there we go. And notice in GeoGebra they give us the equation of it right here, negative 3x minus 1. A little familiar, isn't it? Alright, now let's draw the normal line. So that's the perpendicular line through this point, perpendicular to the tangent line. Well, that looks a little bit different, but we can put in y equals mx plus b form, and we can see once again y equals 1/3 x minus 1. Looking good. If you have any questions, please write them down and bring them to class. Thank you.